Again, we're going to open an Excel. Little editing. Oops. All right, so first things first, we always have to get the mean and the standard deviation, so let's do that. All right. Well, so for the critical value, we've got 12 different video games. So what's going to be our degrees of freedom? 11, because there's always one less. And we want a 99% confidence interval. So what should the left tail be? Yeah, 0.05. So we're going to go the inverse, 0.05, and 11. And again, we really want it to be positive, but I'm just do that to make it positive. All right. So there's our critical value. So the error, well, it's got three parts. You've got the critical value. You've got what the standard deviation was, but that's the standard deviation if you take one at a time. If you do the standard deviation taking groups of 12, what do you do? When we do standard deviation of a group, you have to divide by that square root of the size of the group, right? So that guy divided by square root of 12. So we think the mean should be close to what the sample mean was, the 4,000 or 4,300 guy. Our possible error is 350. So it's the 43 minus the error, 43 plus the error. So the interval. Bottom is the mean minus the error. The interval top is the mean plus. Okay. So we think the mean should be about 4,300, and we're, what was it, 99% confident? I forget what our number was, but that it's actually somewhere between 3,900 and 4,700. Okay. Down to one decimal place, so that will be 0.3. Let's do one more like that. The study was designed to test the effectiveness of magnets on treating back pain. 40 patients were given treatment with magnets and also sham treatment without magnets. Pain was used on a scale from 0 to 100. After the treatments, 40 said they had pain scores of 11 with standard deviation 2.1. After the sham treatments, they said they had pain scores of 9.3 with standard deviation of 2.6. So what's the 95% confidence interval for the ones given the magnet treatment? Okay, the first question is, are we going to use T or Z? So in that flow chart, what's the first question we always ask? Yeah, is in at least 30? Is in at least 30? Yes, so what can we do? Yeah, we're going to use Z, all right? And we're doing 95% confidence interval, so So I'm going to go normal inverse. Point. So 95 in the middle means each side's 0.025. 0, 1. So my Z is 1.96. Again, let me make it positive because it just bugs me. All right, for my air, well, let's do the two groups. So the magnet group, that's the problem. It was 11 and 2.1, right? 2.1. And the no magnet group was 9.6 and 9.3 and 2.6. So those are my mean and my standard deviation. So the error for each one, well, it's got three parts. It's got the 1.96. What else does it have in it? Yeah, it's got the square root of 40 in the denominator. What's in the numerator? Yeah, the standard deviation. So times the standard deviation for a single guy, and then divided by square root of 40. And the other one's going to be the same thing. Just pull it over. So the bottom of my interval is going to be the mean minus the error. Top is going to be the mean plus the error. And the great thing about Excel is we're doing the same thing for both of them. You just copy it over. So we are 95% sure. For those who didn't get the magnet treatment, their pain was somewhere between 8.5 and 10.1. The ones that did get the treatment, the pain was somewhere between 10.3 and 11.6. So what do you think about this treatment? Not only does it not work, it makes you worse. Right? And the people who had a sham treatment, the biggest pain for the biggest possible average pain for the sham is smaller than the smallest possible average pain. So there's no way that this is good. So it was 10.3 to 11.6, I think. Oops. No, okay, let me go back. 10.3 to 11.7. And then for ones that had the sham treatment, it was 8.5 to 10.1. And they do not overlap. So the magnet treatments are less effective than the sham treatments. If they overlap, then you couldn't say for sure which one's better. But since they don't overlap, the sham is definitely better. Okay. And so now we're going to do the same thing. I guess this will be probably the last thing we talk about today. So same thing. Sometimes you have the error beforehand. You want to know what sample size will get you that error. So it says in order to estimate the mean amount of time computers spend on the internet, How many computer users must be surveyed to be 90% confident your sample mean is within 11 minutes of the population mean? Assume the standard deviation of the population is 198 minutes. That's nice. What is a major obstacle to getting a good estimate for the population mean? Use technology. Find the minimum required sample size. It's weird. I would say that this one, since they actually gave us the population standard deviation, I would say that there is no obstacle. But let's just try it and go from there. All right. So again, the error, well, it would be either critical Z, S over root N, or if you can use Z, it'd be Z sigma over root N. This one, since they gave us the population standard deviation, there really shouldn't be any problems. It should just be, okay, I just wrote the same thing again. All right, the error, we wanted 11 minutes. ZC, we wanted 90% confident. So how do I get ZC? Yeah, norm inverse. And what do I plug in? It was 90%, I think. 0.05? 0.5, 0, 1. So 1.65. Whoops, 645. And then said 198 is the population mean. So 198. I don't know where my number just went. Over root N. So if you get root N by itself, well, it'll wind up on top. So the square root of N is 1.645 times 198 over 11, and then just square both sides. So that guy, 198 over 11 squared is 877 people. That's a lot of people. What's the major estimate to getting, yeah, there might not be 877 people to survey. I mean, it would also be kind of hard to predict exactly how much time is spent on the internet. But I think both of those are bad. I'll say that one's worse. Okay. It's like, how much time do you spend watching TV a month? Like, to the nearest minute. Okay. Don't you love it when it says, what isn't quite right with this exercise? The means for college students for exam, range rule of thumb to make a rough estimate. Possible scores are from that to that. Use technology to find the estimated standard deviation and determine the sample size. I'm not 100% sure what they're wanting. Let me guess right quick. 1,500 divided by 4 is 375. Okay, so all I did there was we said normally 95% confidence interval is pretty typical. And that was one of the things we talked about even before we got to the normal distribution is that for a bell curve, 95% in the middle is 2 standard deviations on either side. So all I did was said, well, if that was from 17 to 220, well, that's 1,500 from end to end. If that's 2 on either side, I divide that by 4, right? 2 on either side would be 4 across. So I just divide that 1,500 by 4 to get that. All right. If you want a confidence level of that, then the minimum sample size is, so you want a margin of error of 100 points. So we're going to do the same thing. So 100 is our critical Z, which for 95%, you can punch it in, it's 1.96, which remember it's basically 2. That's why we say the 2 standard deviations is where that comes from. Times the standard deviation over square root of n. So, and if I got it by itself, would be 1.96, 375 over 100 squared. Oops. $54. Or be 55 when we round it up. So what isn't quite right with this exercise? Does anything seem shady about what we did? So let's look at the terms that we just multiplied together. So 1.96, nothing shady about that. That's the 95% confidence interval to Z. The 100, that's the error we want. So there's nothing weird about that. What about the 375? And we didn't really pull it out of the air because we said, okay, well, if it was bell-shaped, but it's not really accurate either. I mean, it's, oh, but this means, okay. All right, well, I was wrong. Okay, it happens sometimes. You're wrong too sometimes, aren't you, Ty? Yeah, it's okay. So apparently they say, well, if on a test it only has kind of, I would think on a, I don't know what the, yeah. It says 100 points is a little bit too much of an error to really mean anything, but okay.